So, guten Morgen. Ich habe Deutsch im Gymnasium gelernt, aber ich habe alles vergessen. So I will switch to English. I could do French as well, but I guess English will be easier for everybody. So yeah, I'm Guillaume Laforge. I'm working for Google Cloud. I've been at Google for almost 3 years now. And I'm a developer advocate, so that means that, of course, I present the new stuff we're working on, but I'm also glad to be here to gather feedback from you, things that work, things that don't work, or features you'd like to see, etc. So whenever you have some things to say or some things you'd like improved, etc., I'm happy to be the advocate for you, for the developers, to bring to the attention of our product teams. So I'll be speaking about the novelties, the new stuff on the serverless offering of Google Cloud Platform. There's a bit of irony in the sense that it's, let's say, the not so new stuff, because next week there will be Google Cloud Next, the big Google Cloud conference in San Francisco, where there will be new stuff. You know, I cannot tell everything that's going to be announced next week. But some of the stuff you're seeing here that is in beta or alpha, etc., might move to the next stage. So at least that's a little bit of a glimpse of also some of the announcements that will be done next week officially. So the Google Cloud Platform, for those who don't necessarily know, so that's really the part of Google that provides various services and servers and technologies and APIs to developers so that they can build their own solutions, projects, etc. in the cloud. And the Google Cloud is it's actually leveraging the very same infrastructure that's been used for years by Gmail, Google Drive, and all the other, or YouTube, etc. So that's using the same infrastructure with all the undersea cables, the data centers, the edge locations, and so on. And it's obviously available globally in many areas, many countries. So it's super fast and efficient infrastructure, which is pretty good. In terms of offering, there's lots of stuff. And I barely know, I just scratched the surface, and I'm actually myself focusing more on the compute side of the story. So compute engine for VMs, Kubernetes engine for running your Kubernetes workloads, etc. But myself, I'm focusing more on the serverless related products. So Google App Engine, Google Cloud Functions especially, and some other useful tools I'll mention later on that completes that overall picture. And when we speak about serverless, this is, well, it's an old joke now, I guess, but it's not the new serverless data center, because, of course, there are servers somewhere. And those servers are there behind the scenes without you really knowing. That's the whole point of serverless. In terms of operational models, so you don't have to provision clusters, manage those machines, or the underlying operating system. Because of that, we also, the cloud provider here, Google, takes care of the whole security lifecycle. So whenever there's security patch to be applied, it's done automatically, so you don't have to track that yourselves. It's also pay for usage. So if you don't use, let's say, a function or an app, it's not going to cost you any money. That's the whole point. So it scales to 0, meaning also $0. But when you've got a peak of traffic, we can have more instances serving your traffic. So it scales proportionally to the usage. In terms of programming model, we're more on a, rather than a monolithic approach, we are more on a service-based approach. So it's a great fit, obviously, for things like microservices. So services, whether as we'll see that in the demo I'll be showing you in a few minutes. So you can have services within the same applications, or you can use different functions if you're using functions for your services. You can answer incoming HTTP requests, or also another model that is very common when you segregate, you separate your microservices. That's an event-driven approach. So for example, if there's an incoming pub/sub message that arrives on some particular topic, then it's going to trigger automatically a function, for example. So it's really event-driven. The other aspect I wanted to mention, so it's the openness aspect. Usually when you go with a cloud provider, there's some adherence to the cloud that you are using, obviously. But things have also evolved, I would say, in the sense that, for example, if you, just to illustrate this, the Google App Engine, it's actually an old product that's 10 years old, but that evolved progressively across those 10 years. And before, you were locked in the sense that you had to use the built-in services, or you had limitations. There were things you couldn't do. But the latest trends there was to allow developers to use any library with their App Engine application, for example. So there's no limitations like there were in the past. So we're opening things up. And as I will mention also later on, we're working on some new things around also making not just apps and functions scale serverlessly, but also containers. And we have also worked on some open source strategy with other partners to make things more open so that you can more easily move from a cloud provider to another, or deploy your stuff on-premise as well. So we'll see that in a little moment. I'd like to illustrate those serverless solutions on a spectrum. So the sole axis of that spectrum is how much management there is and who's doing that actual management. So when everything is really managed on the cloud by the cloud provider, you have products like Google App Engine or Google Cloud Functions, because you just deploy your code, your apps, without having to care about this underlying infrastructure. But also the solutions we're working on also allow you to deploy your stuff on your own container-based infrastructure with Kubernetes, and then it's managed by your team. But it can still be serverless in the sense of the developers who actually use that infrastructure see this platform as a serverless platform, because they also just deploy their code to that platform. So a big portion of my talk will be on the top left-hand corner, App Engine and Cloud Functions, and my demos will focus on that. But I will also mention the stuff on the below the axis. Especially the stuff we've been working on serverless containers, to make containers scale the same way with the same attributes as functions and apps. So we have purely serverless managed by the cloud provider, by Google Cloud. We have App Engine and Cloud Functions. So App Engine is, as I said, 10 years old now, and it's a highly scalable serverless web applications. So if you look at things like Snapchat, who's ever used Snapchat? Yeah, a few hands, not that many, or you're too shy to say you're using Snapchat. That's my kids love using it. For example, it's using Google App Engine. So when you're using Snapchat, under the hood there are, I don't know how many instances, but probably millions of instances running Snapchat, because it's really something huge. So the unit of deployment is an application, or an application that can be split in services, and it's there to receive incoming HTTP requests. So it's especially great for web payloads. Cloud Functions, it's more event-driven in the sense that it can be triggered by events like, so as I said, messages coming on a pub subtopic, new files that have been uploaded on Google Cloud Storage. What else we have? We also have Firebase, if you know Firebase for mobile development, etc. Firebase-related events, or like authentication, etc. Or Firestore, the NoSQL database that we have. For example, whenever something is written in the database, it can trigger a cloud function. So it's like the modern version of stored procedures, if you will. So the unit of deployment is, and of development as well, is a function, and it can react to events. You don't necessarily need, on top of that, a special gateway for HTTP traffic, because functions also accept HTTP traffic. So let me illustrate those things with a little application, a little demo that I've built. So it's a picture for sharing, it's an app for sharing pictures. So for example, I'm going to take a picture of you. So let's see, so you can actually go to this URL if you want and take some pictures. Now I'll explain what the app looks like. So so it works on your mobile phone or your laptop, obviously. So there's a simple UI where you can view the pictures that have been uploaded and that have been taken already. There's a little red, pink button so that you can take pictures. I think that's this one. So there's you can see yourself or what you're gonna take. I forgot to mention this. You saw on the left at the bottom the little labels. I'm using the machine learning API, the Vision API, to get the labels of the stuff that's in the pictures. We have the most popular tags, so the most popular labels, so things that are seen in those pictures, and ordered by the most popular and most frequent tags. And there's also an admin interface for me, so that because there's no authentication, so I don't want anybody to push pictures that I wouldn't like to show up, on stage, and you never know what the audience, and especially people see videos afterwards, and sometimes I see people using my demo application like weeks after, and it's funny to see the kind of stuff that people are taking, the kind of pictures they take. So that's the UI. I'm going to show you perhaps more directly, show you the UI. Yeah. Okay, so that was a picture of you that I took, the picture of the stage. So you can see, let's say, like this restaurant tag is there. Yes. So this one's not restaurant, but yeah, restaurant. Why not? You can see the most frequent tags here. So let's say car. If you want to see pictures of cars, that's a train actually. Car, some cars. I don't know where's the car there in this picture. Okay, what else? So that was the most frequent tags, and you can see again, so you can navigate through the tags by clicking there. So if you want to see some electronic stuff, etc. And the other part, that's the admin interface. Perhaps I'm going to increase the font size a little bit. Oops, no. I'm coming back to so I have a dedicated admin interface where I can see the stuff that's been published as well as stuff that is filtered, because the Vision API that I'm using from my function also allows me to filter the pictures, the incoming pictures, because sometimes, this one is actually interesting, I'm going to show you. The Vision API thought it was blood, so it said it's there's a violence in this picture. But it was actually a dessert with strawberries and cherries and so on. So that was not blood, I'm sorry. But sometimes like this one, it's just like the skin, but it could have been something else. And it's not. It's not this something else. And I'm going to dive into the code afterwards. So let me switch back to the slides and just show you the architecture of this little demo. So, yeah, I need to click. So first of all, we take a picture. So the user goes to either through the phone or a web browser, go to the front end, which is actually a Google App Engine application, which I developed with in Java. So there's both the static assets, so all the CSS, HTML, and so on, as well. So I'm using Vue.js for the front end and static assets, HTML, CSS, etc. Plus, there's also a part which is the API that serves some JSON representation of the pictures, labels, etc. Once the user clicks on the picture button on the shutter, the picture is uploaded to Google Cloud Storage. I also add some metadata into a Cloud Data Store, which is a NoSQL data store from Google Cloud. I'm adding things like the URL of the picture and some empty columns about the metadata, because I'm going to decorate this with the labels and things like that. I'll give some more details. Then, once the function is stored on Google Cloud Storage, a function developed in Node.js is going to be triggered. This function is going to call the Vision API, and the information, the metadata that I'm going to retrieve, that's the labels, so what's in the picture. The colors, perhaps you saw there was some colors around. So the dominant colors, like this peach and blue and light blue, etc. That's also coming from the API, the Vision API. Coming back here. Okay. So once the Vision API returns, I'm going to, so one step back, the function is going to store the additional metadata, so label, dominant colors, main color, and whether it's a picture that is okay to be shown, because I'm filtering for content that's not, that shouldn't be shown. Then, at a regular interval, I'm also using another tool that's great for serverless, which is Cloud Scheduler. With Cloud Scheduler, at a regular time, every few minutes, I'm actually launching a little pops-up heartbeat that's going to trigger another function, and this function is going to look into all the tags, all the labels that are stored in the data store database, and it's going to compute the most frequent tags. And there's another table where I actually cache the results of that computation, because I'm going through all the pictures. So it's not perhaps the best way to implement this. I could, do the frequent counting on an ongoing basis, but I did it that way. So every few minutes, I'm going to upload the calculated most frequent tags. So that's about it for the flow for the users. For the administrator, there's the admin front end, which is a Go application that a colleague of mine developed. So also something, if you saw Nicolas Frankel's presentation yesterday, something he said that I liked was the fact that one of the nice things about microservices is the way you can also, because team development doesn't necessarily scale once you've got big teams, it's also a great way to separate the work across different teams. So it's not that I had a huge team like me and my colleague, but at least my colleague could develop on his side the admin module, the admin service, without interfering with the rest of the development of the overall application. So I'm not a Go developer, but my friend, my colleague, developed the Go frontend. So there's a bit of a mix of some Java, some Node.js for the functions, and also some Go for the admin interface. And let me show you how it's been developed. So here, I've got my front end. So there's the front end, there's the admin module, and here the two main functions I'm using. So the front end, as I said, is Vue.js front end, which talks to a Java application on, so here it is, a Java application on Google App Engine. To keep things simple, I used a small framework called Spark Java. So it starts super fast. It's nice, and I like also the syntax. So I'm gonna just do this so that it's easier to show the structure. Yep, this one. So a part of this application serves the static content, so the Vue.js code, etc., the CSS and so on. So that's that's what's there. I'm serving the static content there. I also have special path for retrieving all the tags, retrieving all the pictures by a certain tag, and I also have the API. The API part is what is being called actually from the Vue.js frontend. So the Vue.js frontend gathers, gathers the pictures, the most recent pictures. Excuse me. I also the post actually is the one uploading the picture. So this is the one getting the list of most recent pictures, and I also can see the pictures by tags, and then the latest tags is there. So if we look at, let's say, perhaps this one, I'm using the data store to store the metadata and the URL of the picture in this entity. It's a document in this data store storage. I retrieve the payload of the picture, so I sent it via a post request, base64 encoded, and then I'm storing the picture on Google Cloud Storage. So it's pretty straightforward. For things like which one, so listing the pictures, so I have a dedicated method there. I'm using, again, the data store to retrieve the list, because that's where I store the list of pictures. I'm retrieving the list of the most recent pictures, ordered by timestamp. And I just want to get the first 20. I'm going to show just the first 20. And I can also filter on the tags if I want to just show pictures of cars, electronics, whatever. And then I'm basically iterating over the results to give that to through the API to the front end via Ajax on the Vue.js front end. So it's not very complicated. So this is the main service. I also have my admin interface. So those two. So I'm going to show the Go front end as well, the admin interface. It's actually two services of the same Google App Engine application. So you can have as many modules, as many services inside one application. In terms of concurrency as well, you can serve many requests from App Engine concurrently, whereas a function serves only one request in terms of concurrency. So the Go application, I'm not a Go developer, so I'm not necessarily going to go through that too much, but it's using also the data store API, ordering, limiting, filtering, etc., to run the same queries to show like the filtered or non-filtered pictures, etc. And I'm going to show you as well the, so I think I need to increase the font size a little bit. So this is the Google Cloud Console. So here I'm showing the functions, but where's my App Engine? But I have, failed to load. Perhaps I'm not authenticated. Yeah. I shouldn't use my corp account. Never mind. So I can see, well, the versions, that's not what I wanted. No, the services, that's what I wanted to show. So I have two services deployed, the admin interface and the default, the web front-end application. Also something that's nice, it's things like, so you can see the various versions which are available, and I can have several versions of the same service running at the same time. So for example, I have this ugly one, which has a coral background color. And what's nice as well is that I can even do traffic splitting. So I could say, so the current one, I could say, do a traffic split and spread, let's say, 50%. So I can do things like, canary release, blue-green deployments, all that kind of things. Let's say split by random, and I can save that. And updating traffic split, it should be, doesn't take very long usually. And I can do easily traffic splitting across different versions of my application. So the next time I'm going to go there, updating, it's still updating, but yeah, so if I go back here, you see it's already, the traffic splitting is already in action. So once in a while I get the coral background or white background, coral, white, etc. So it's fairly easy to do different percentage for different versions. That's pretty cool. I like this feature a lot. Okay, and for the functions, let me show the functions now. So two functions. One, that's the Vision API here, Node.js app. So the Vision API is the function that calls the Vision API is triggered when there's a new picture that's uploaded. So I'm using here, so I define the call that I want to make. So first of all, I'm retrieving the file that's been uploaded, the name and the bucket in which the file has been uploaded. Then I'm preparing a call to the Vision API. So that's here because I want to annotate those pictures and I want to have the labels. I want to have the image properties, for example, the dominant color. I want also to use the safe search detection, which tells me if the content is violent, racy, etc. So I'm doing that call, and then once it returns, so I'm filtering on whether it's safe or not safe, and then I can update the data store with the additional metadata, the labels, main color, it's been processed, it's been filtered or not, and the reason for the filtering, and the timestamp. So that's where I'm updating the metadata in data store, and then some logging information. The other function, so this is this one. So this one, yeah, I could also show you this in the UI. I have, so this is App Engine, but I have, where's Cloud Scheduler? I'm going to search for it. Cloud Scheduler, it's there. And I should be seeing Heartbeat. So I have different ones. So there's one that updates like every minute the most frequent tags. I don't really need it. I will need to change it to 1 hour. And interestingly, I kept both. And I also have a load generator when I want to do some stress tests. So I'm using the Cloud Scheduler to ping a function. So it pushes a little pub/sub messages that calls my function. And this one, it's calling the backend API to find all the tags, and then I'm doing some filtering, ordering, etc. to find the top frequencies. And then I'm updating the data store with there's a document which contains the most popular tags. So I think that's about it for the code. So I have two functions, two services in one App Engine application. And I can easily mix and match both apps and services and functions depending on my use case, whether it's more event-driven for the functions or more, let's say, front-end driven or back-end API with serving HTTP payloads. Right. So let's switch back here. So beside this, some of the more recent announcements of things like new runtimes, new features. So as I said, App Engine is available in different shapes, different runtimes. So you can use Node.js, Python, PHP, Go, and Java. So between parentheses, you have the current state, the current beta, alpha tag, but those tags will actually change next week, and most of it's not recorded. Okay, so I'm telling you some of the stuff that's in beta, so don't look at the video or cut it or something. Some of the stuff is going to be released next week as GA, generally available. Although the Java 11 will be in alpha, I think, still in alpha. So I changed this slide to reflect that at least. And there's actually, if you want to use, I'm a Java developer at heart, so if you want to sign up for the alpha of Java 11, there's this URL that you can use. I can share it with you afterwards. We're looking for additional testers before we release it to beta and then GA. For Cloud Functions, we had Go, Node, and Python. So I used Node in my demo, and I've been working with the engineering team and the product managers on the Java version. So we're currently working on this, and I'm going to demonstrate that next week. We have so the Go. Yeah, something I wanted to mention about the Go runtime. It's so this is just a hello world, but so you can specify, there's a runtime flag to say which particular runtime you want to use. And, so I thought I had a slide about this. We have a support for vendoring and modules. For those who are Go developers, they know better than I do. Because before it was a bit less straightforward to go with vendoring, but now modules are also supported, which is nice. In my demo, I used Node 6, but I could have used Node 8, and we have this alpha of Node 10 as well. So you can use, for example, the async await support. So that's where you see, like here, you can see the async keyword, or there, await. So it makes the code more imperative-like, instead of doing promises or callbacks. So it looks more like imperative code, so it's easier to develop and reason about. So I quite like this support of Node 8 and 10. Something I didn't show that in the code, but there's the support of environment variables. So for example, there was a function where I was telling where the API endpoint is, and I've passed this data point as an environment variable. So you can set one variable or use envar files, which define the different variables that you want to have. So this is with a YAML file, or there are other flags that you can use for environment variables, and then let's say in Node you can do a process.env and .foo to get the value of those environment variables. What's nice with Serverless is that it scales to 0 or to infinity, and that's great. But sometimes you may have some other resources that need some limits, in the sense that, let's say you're talking to a backend database, but that can only accept a certain number of concurrent connections. So you can also limit the scaling for functions. So if you want to say, okay, not more than 100 functions, 100 function instances in parallel, because otherwise there's not going to be enough database connections available for the upcoming requests. So the requests are queued till a new function is available. There are additional security controls for functions. So all the functions actually share the same identity and rights. So let's say if someone had access to a particular function or be able to hack a particular function, potentially we could imagine that since it's let's say very open in terms of the rights, the roles that you have. They could do some malicious things. So something that we're adding is the ability to have some finer grained control in terms of security. So there are two things. First of all, on this slide, I'm showing the command line tool, the gCloud SDK, that you can use from the command line to update the IAM policy binding to say, okay, something I wanted to mention as well is that HTTP functions, when you create an HTTP function, it was public by default, but now it's going to be private by default, so it's not accessible by default. So you have to say, okay, now I want to make it public. So this first example says, okay, this fn1 function, I want to make it public. So I give access to all users. They can invoke my function. But for example, for the second one, what is it doing? Yes, for function 2, I want this function to give so it's saying that I want only the user function 1 to be able to call function 2. So I'm sure that there's only function 1 that can call my function. The other thing in terms of identity, you can also set a service account for each function to give it a special identity. So I can say, okay, so in this one I'm using again function 1 and 2. So for function 1, I give it a certain identity, and I can control the rights on the IAM area of the Google Cloud Console, or use it from the command line as well, and say, okay, I want to say this function uses that service account. So you have more fine-grained control by using the IAM roles. And for example, this second one, so this one has the right to call functions, and the second one, the second function, for example, has the sole right of accessing the Cloud SQL library. So even if someone had access to function 2, they could write to the database, but for example, not call other functions. All right. So beside this, there are additional, so it's services that you can use in the context of your serverless development. So there's cloud tasks which allow you to distribute the workloads, for example, doing things like fan out, etc. So you can use cloud tasks. Before, it used to be a service built in Google App Engine, but we're externalizing those services to make them available to all the Google Cloud products. So there's cloud tasks, there's an alpha, is it alpha, yeah, or beta, I think. I forget the actual status, but it might change next week. I think it's going to be GA next week. So I guess you won't need the sign-up form anymore after next week. We also have the scheduler that I used in my demo. So if you want to, at regular intervals of time, you can trigger something, send pub/sub messages, or call a URL, whether it's a URL of your own functions and apps, or it can be a remote URL. Think webhooks and such. So it's useful to have those services. And I'd like to finish and say a few words about the cool stuff that we actually announced last year, but that's going to be in the spotlight next week. Serverless containers. So we spoke about functions and apps, but you can also use containers in the same way as those serverless functions and apps. So if you want to have the same characteristics, pay as you go, scaling to 0 up to infinity, etc., you can have the same characteristics as well with serverless containers. So that's what's highlighted there. So when you're limited, let's say, by the available runtimes in terms of languages, etc., available on App Engine Cloud Functions, you can also bring your own container and put anything you want under the hood. If you want to develop in COBOL or whatever, why not? You could put that in a container and deploy that on this new product. So yeah, you can use your pre-built Docker images and push that on the same infrastructure as Cloud Functions. There's also a link for the sign up, but again, it will not be needed next week. And so this new thing we've been working on, it's also open in the sense that we've been working with the community, with partners, on something we call Knative, which is an open source project that allows you to have the equivalent infrastructure, but that runs even on-prem or on other Kubernetes powered infrastructure. So Knative is an open source project that has 3 components, 3 Legos, let's say, for building those containers, for serving the workloads, and also for replying to incoming events. And it's something we've worked on with other partners, Pivotal, Red Hat, IBM, etc. So it's really a set of building blocks. So it's not a product. You cannot use it as is. You have to use a platform that's built on top of Knative. But once you use a platform on Knative, a workload or an application that you've created and deployed on Knative will work on Google Kubernetes Engine, or it will work as well in another place that's using Kubernetes with the Knative support. So for example, you'll also be able to use your own Kubernetes cluster on Google Kubernetes Engine if you want, thanks to a dedicated add-on. And then your apps, your containers will be, it will be possible to move them on-prem, on Google Cloud, or elsewhere where it's supported. So that's about it. Thanks a lot for your attention. I'll be there, so we might have 1 minute or 2 for some questions,
sure.
And otherwise I'll be there.
You're a great moderator already. So
thank you.
Thank you very much for the talk.
Thank you.
So indeed, we have time for 2 questions. So.
Hey, thanks a lot for the nice talk.
Thank you.
I have a question about debugging and monitoring, or in particular, let's say, about Cloud Functions. Might be a long answer, but like, how do you see that your function doesn't work or something goes wrong?
So we have different tools which are available for you. So there's, well, I won't show it, but there's the Stackdriver logging interface. So you can see all the logs. You can filter. You can even do reports or export that data and do other, dashboards and things like that. You have Stackdriver errors to monitor errors that are happening and that are not caught by your code. So you can also, look at the stuff that's unusual and then act upon that. And depending on the language and runtime that you are using, there's also Stackdriver debugger and profiler, so that you can look at what's going on under the hood. And one of the nice things that I like about this is there's what we call what is it called? You can add a log point, not just like a debugger. Basically, you can put log points in live running code and add additional statements to see, let's say, the value of a particular field. So that's super useful to be able to even debug production directly. So that's something that's pretty cool. So it's not available across all the runtimes, I think, but some of them, I forget which one, do support that, like Java and Node, I think. So there are different tools for monitoring, debugging, tracing, etc. that are available. Yep.
Any other questions? Okay, this seems currently not to be the case. So thank you again very much for the talk. And then I have one more information for you.